Okay. Can you hear me? I couldn't hear anything.
Yeah, now we can hear. Well, we were working on the number 3,
Okay.
and then we passed number 4, and then there you go. I wasn't recording. So number 3 we think is the P without hat.
Number
Yes, the third
three.
one. Yeah, number 3, the single P.
Yeah. Yeah.
Yeah.
Okay.
And then we were talking about number 4.
Mm-hmm.
It gives us the values,
Mm-hmm.
and then we need to identify if it's true or if it's false.
Right.
Confidence interval or satisfy. Confidence interval. Because, um,
Are we are we recording now, Katie, or no?
yes, we are. Yes, we are now recording.
Okay. So if you do so that's the confidence interval. So that one's n times p hat, and it has to be greater than 10.
Mm-hmm.
And that one is the 100 times the 0.10, and that's exactly 10.
Yeah,
Right.
there's
Or the n and then times the 1 minus the p hat,
So
which
that's
is
equals
90.
90.
Yeah. So it's
So
good.
is it true?
It's good.
Yeah,
It's true.
it's true.
And then the other one is just the same exact thing, but you're using just the p with so n times p, and that equals 25, and then n times 1 minus p, and that was 75. What did I get? Yeah, 75. Was that right,
So
Moses?
that's greater. That's greater, right?
Yeah. So it's true as well, right?
This is
Yeah.
true. Okay.
And then so number 6. So then, if I understood this right, so you're taking the first degree murder trials, and there were 60 of them. 45 of them were found guilty. So to find the P, you would do the 45 divided by 60
Mm-hmm.
and
Yeah.
get 0.75.
0.75.
Yeah. Is that what you
Okay,
got?
so it's 45 divided by 60, right? 60.
Mm-hmm.
Yeah, that's the P hat.
So point 75.
Yes, but you have to put another 0.
Okay, so it's 0.750. Yeah, because
Yes.
it's 3 decimal.
Yes.
Okay.
And then the next one is a long one. So you want to find the confidence interval. It's for 95% of those that are found guilty. So then you're going to do the 1.6, and you're going to times that by the square root of 0.75 times 1 minus 0.75 divided by 60. Is that what you guys get?
Yeah. That's what I was working on right now.
1.96. That's the 95% interval. And then it's the square root of 0.75 times 1 minus 0.75 divided by 60.
Is that 11? 0.11? I don't know.
Yeah, 0.110.
Okay, 110.
And then
Wait, what are you talking about? 0.110.
that's the answer. What did you get?
No, I was barely working on that one. So how do you? So it was a 0.75 minus the z-score, right?
No, it's 0.96. Did you say 0.96, Pauline?
1.96.
1.96
times the
square root
of the 0.75 times 1 minus 0.75 divided by 60. And so you're finding the square root of point. So after you figure out the middle part in the square root, then it was 0.003125. And the square root of that was 0.559. And then you times it by the 1.96 and you get the 0.110. Well, you get 109.5673.309, but when you round it up, it's 110. I love you, bud. Have a good night. Sweet dreams. What do you get, Moses?
I'm not getting anything yet. Hold on.
Okay, no, that's okay. Take your time.
Yeah. So we're still in number
Number 7.
number 7.
Yeah, it's 0.110. And then we need to put
But
the
isn't that,
lower bound.
are we working right on the confidence intervals for this one?
Yeah, so it's the p
Yes.
hat.
So we're trying to get first the margin of error, right?
Yeah, they want the margin of error right now.
So what did I get? It's 0.056. I'm trying to figure it out.
So that's inside the square root. You just figured out the square root. So now you got to take that 0.0559 and times it by the 1.96, which is the confidence interval for 95%.
And that's to get the margin of error?
Yeah, and so the margin of error is the 95%.
Oh,
Yes.
okay. So you're saying so that times 1.96.
Yeah.
$1.96 times. And how much did you get? 0.110.
10.
Is that what you got?
I'm getting 0.109.
0.109. Yeah, so it's 110.
Okay. 110. Okay.
Yeah, because you have to round it to 3 decimals.
And then you take that margin of error and you're going to do 0.75 plus that and then 0.75 minus that. And that's how we're going to get our upper and lower bound.
Okay, which
okay, one more time. Sorry, I'm just kind of confused. 0.101?
Minus?
No, 0.110 because it was 0.09 something. And I erased mine already, but it should have been 0.110. Is that what you got?
He got 0.190 something.
0.109. That's
okay. And then what came after the 9?
7.
So then you round it up, and it's going to be 1.110.
Okay.
If it's 109.7, and then you look at the 7, you're going to round the 9 up to a 0, and then.
Okay.
Does that make sense?
Yes.
And so for the lower, we need to put 0.110 minus. You say minus?
No, you would do the 0.75 minus the 0.110.
0.17 minus 0.110.
Well, but you aren't supposed to round. You're not supposed to. Okay, so when you're giving the answer, you round. And so that would be the 0.110. But you want to keep the full answer of what that 0.1097, whatever it was, and subtract that from the 0.75 to get the lower bound. If you round up, we might be missing a number or something like that.
Oh, okay. Yeah.
Let me try it because I already figured it out. But it's 0.1095673.309. But you've got to use that whole number to do the 0.705. Subtract subtract 0.75 minus 0.110. Yeah, no, it gives you the same answer.
Is 0.64?
0, because they want 3 decimal places.
Okay. 0.640. Okay, Pauline, we decided that you are going to make all the videos for the next students that take this course.
No, this course totally confuses me. I don't even understand half of this stuff. Okay.
Okay, Pauline. So what formula are we using right here for this?
Okay, so this is the interval one. So on chapter 16, we were using the P.
Minus this score.
Yeah, the P hat. I mean, we were using the P. Now in 17, we're using P hat. So the formula is P hat plus or minus the Z score.
Okay.
Times the square root of P hat times 1 minus P hat in the parentheses.
So in this case, P hat is 0.75, right?
Yes.
Minus 1.96.
Yes.
Then times what we got in the other one, right?
Well, no.
Was it?
Okay.
No?
So the margin of error is everything after the plus or minus sign. So the P hat is plus or minus, so it'd be 0.75 plus or minus whatever our Z score was, and whatever our margin of error was, and the margin of error was 0.110.
Okay.
The whole margin of error, we figured that out. But my worry is that if we round down to the 0.110,
right. Yes, not gonna.
Yeah.
So we need to do before we round it, right? The margin of error before it was rounded.
Yeah, before it was rounded. If we're going to do more with it, if we're just going to stop with the margin of error, then then that's where we round. But if we're not going to round it, now we're going to add it or minus it from the P hat. Then we're going to want to keep it, because when I did the lower bound, it was fine. But when I did the upper bound, when I did it with the whole number, the whole long number, I got 0.859. But when I did it with the shortened margin of error, the 0.110, I got 0.86. And so I don't know how particular he's going to be on that.
Okay, what was the margin of error before rounding?
Before rounding, I got, hold on, let me see if I saved it, because I think I threw it away. It was 0.10956.
Yeah, that's what.
Okay, so 0.109567339.
So to the number we need to. I'm sorry.
So when we subtract 0.75 minus 1.96, then we multiply it by that.
Ask me again.
So then doing the confidence interval formula, then we get 0.75 minus the Z-score 1.96, then times the margin of error. Is that correct? Are you understanding what I'm saying?
Yeah, but the 1 point. Well, no, I don't know. So okay, so the confidence interval for this chapter is that it's the P hat plus or minus. That part's in a own little entity. The margin of error is the Z score, or the critical value, whatever Z is, and then this one it's 1.96. That's included in the margin of error. We don't include that with the other part. So like we figured out that the margin of error already was 0.110. So now all we have to do is to find the upper bound and the lower bound. We just have to do 0.75 plus the margin of error, the 0.110, and then 0.75 minus the 0.110. The margin of error is the big part of it. It's minus the, I don't know if I'm answering your question, Moses, or not. I really, I don't know. I'm sorry.
That's okay.
So if you take the margin of error, or if you take the p-score, which is the 0.75, and you minus, because they want, for number 8, they want the lower bound, you're gonna minus the margin of error, which is the 0.110. You come up with 0.640. Is that what you got, Katie?
Yes. Wait, just a sec. My computer is showing me all my. I go. You mean the next one, number 8?
Yeah.
Is I got 0.640. I got 0.64 each of me because it's 3 decimals, 0.
Yeah. And then to get the number 9, you just do 0.75, which is the p-hat, and you plus the margin of error, which was 0.110. And then you get 0.860.
Yeah, I got it. 0.860.
Actually, I see what you're saying now. I understand. Because I was trying to, when I was doing I was trying to do it step by step by the formula. So I was going P minus z-score, and then times the square root of whatever the margin of error.
Yeah, I forgot that the margin of error for a long time included the z-score. And then so do we all have that formula? You guys have that formula, the p-hat plus or minus the z-score? Okay.
So for the upper bound is 0.850.
0.
850?
For the upper is 0.860.
Yes. Which is before round there was 0.859, right? So 0.860.
Yeah. Yes, you're right.
Okay.
So if you increase the sample size from 60 to 80, what do you expect to happen to the confidence interval? And I wrote that down today because that was going to confuse me. So if you increase the sample size, then the margin of error will go down, and so the interval width will go down. So if I wrote it down right, it will decrease. If the sample size goes up, what do you expect to happen with because you're going to get closer to the mean, and so 85% is going to be, 95% is going to be closer to the mean. So it would decrease. In the videos, they said that specifically. He pointed out that if the sample size increases, then the margin of error decreases, and the interval width decreases. So I wrote that down because I figured it was probably important. It makes sense, though, that as you get more people, it's going to get closer to what it actually is. So it's going to decrease this size. Do I talk too much?
No. It's fine. You help us a lot to understand better. I have to read 2 times or 3 times and trying to figure out the formula.
Yeah, I take my lunches at work and I do this because I don't have time. I came home and just passed out today. I slept for an hour.
Oh, really? I did homework yesterday until 2 in the morning, I think. And then I woke up early this morning and I said I have to read something. I was trying to read my way home and I just wanted to fall asleep. I was there. I fall asleep like for
Yeah,
20 minutes.
little cat nap.
Okay.
Okay,
We are 11.
so 11 is something new that we learned. So to conduct a hypothesis test for one proportion, two requirements must be met. And two requirements must be met.
So that's half of, it's half, this is half, right? No,
Yeah, it's half.
that's half. So
What
this
is the
half.
smallest n?
So what would that be? 20?
Well, but I don't even understand what the question is. Is it related to number 10 at all?
Isn't this for no, I don't think so.
And probably is it related to?
That's what I'm wondering. Is it related to the ones above it or no?
Probably, but the n will be in question. So n is 100. Supposedly in question number 4, and it's 100, and then this is half of it, and half of it will be.
I don't think he's just talking. This one 11 is just talking about the what do you call them? The when you satisfy the if it's greater than 10.
Yeah, but it's saying that it's a hypothesis test for one proportion, and that was two requirements must be met. It has nothing to do with the ones above it. So if P, these were totally different formulas where N equals the Z score or the Z, whatever the critical value over, oh man. They got to, I need more information than this. To conduct a hypothesis test, what is the smallest N that, oh, okay, yeah, no, maybe it is. Maybe it is for the ones above it.
Well, n and above is 100.
No, the N was 100.
Yeah, and well, the only n that there has a amount is a number 4. Then unless it's talking about something different.
Yeah, no, we changed. Right above number 6, it was the first degree murder trials. So the N would be 60.
Oh, yeah.
And then, so the N would be 60 and the P would be 45. And the P hat was the 0.1. No, that wasn't, never mind. That was a 0.75. But they want to know. And it said this is for the next 5 questions. So 6.
Yeah, because the 12 is asking something about n too.
8,
what is the smallest n?
10
can be
11.
In both.
Yeah, so this one's different. This one has to do with the one sample T for proportion. I don't know how to say that. Let me see here.
I think I just got that for the remember the one you were talking about. You try to do a request to get the N.
Yeah, but what's the N? I mean, there we have to know something. We have to know a margin of error.
So you got the P, you got the proportion, which is 0.5.
Oh, I see what you're saying. So yeah, you do 20 then, right?
Yeah.
Yeah, no, I see what you're saying now.
To be 10.
Yeah, 0.5 times 20 equals 10. I see what you're saying.
Yeah, that's what I think it is. I don't know.
Thank you. I could have been here forever. Okay, and then the other one is the 1 divided by 10. is going to be a 0.1. What's the smallest that n can be? So, 0.1 times
what
100.
would it be?
I think it's 100.
0.1. Yeah, 100.
1.1, right?
I'm really sad that we can't take tests together because my brain on some of these just does not work.
And it's like we all have a little bit.
We can.
I don't think so.
You don't have to know. I'm just kidding. So we can take it together.
You're funny, Moses. Okay, so water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. So the researchers suspect that water quality in the area has decreased. Okay, so we know that it's going to be decreased. They conclude that the hypothesis test using a significant of alpha 0.05 with the following hypothesis. So they collected new data, and the N is going to be 80, the X is going to be 38, and then the hypothesis is that it's going to be 0.6 or less than 0.6 is the alternative.
Mm-hmm.
So the conditions are the conditions satisfied. So the P is 0.06 or 0.6 times 80, and that's going to be more than, is it going to be more than 10? Is that 480 or 48, I mean? Or is it 4.8?
So it's 80, what is it? The amount? 0.06?
0.06 times 80 is 48, so that one's satisfied. And then the N
0.06 or 0.6?
0.6, sorry.
0.6.
And then 80 times 1 minus 0.6 is 32. So yeah, they're both satisfied.
Mm-hmm.
Hello. Oh, I was coughing. Sorry, I drink something in my. I have something on my throat that is itching me. Okay.
So you sound like you've got a lot of allergies.
Yeah, here it's humid here.
Oh yeah, okay.
Today is summer, and the whole day I'm inside the air conditioning, and when I need to do something, I go out and it's hot, and then I go back to the air conditioning. It's like that, out and in.
Your body's getting confused.
Yeah, my brain, my everything is getting confused with me. Yeah.
Wow.
Okay,
so the P hat is going to be the X divided by the N.
So it'll be 0.475?
Yes. That's what I get too.
So.
And then find the test statistic, which is going to be the standard deviation, which is calculator. My phone's old, my computer's old, everything is falling apart.
Same here. Don't feel bad. My computer is really old, but it still works because I don't do like difficult things here, or I don't have like those programs that can affect my computer, but my laptop. But still, I told you it makes this strange sound once in a while.
Yeah. Okay, so I've got.
So the test statistics. What is that? I forgot.
The test statistic is going to be this. Oh, crap! I just thought it was standard deviation, but it's not.
Isn't the t value that we were seeing in the other? Or that's something else? Or it's just the mean?
The test statistic is going to be, find the test statistic. The statistic I thought was the X bar, or the X, and they already gave us the, oh, you know what? I bet they're talking about the, oh, I don't know. Hold on. What did we find out already? We found out the P hat. And we found that the condition is true. What is the test?
Can,
That's not the standard deviation. Let me look. What has it been in the past?
I thought it was the T when we were doing the other Excel sheets. Let me look at my flashcards.
This really shouldn't be this difficult.
T. No, but I have
Compute the test.
T. No, but I don't know if it's related to this. Let me see. Isn't it T?
No, yeah, I think
No.
you're right. I think it's the T that we're supposed to find.
You think so? You think it is a T?
I think. Well, in the past, it's been either the Z.
Right, but
the
I don't
Z4
like it how he brings us back to another topic. We're not even.
Yeah, I know. It's
seeing
kind
right
of
now.
confused. It's like you are too into that one before, and you say, "Okay, I know how to do it," and then it's something different. I don't know.
Yeah, and then he
I don't know.
brings you back.
I don't know how I'm gonna pass this course because
We've only got 5 more weeks. Only 5 more weeks, guys. So we can.
I understand half of it.
Yeah.
Half of it I understand, and the other half I don't.
Because when we talk about the mean, but I mean that's totally something different. It's T equals sample mean minus the mean divided by the standard deviation divided by the what do they call it? I don't know. I'm all confused. I got x minus the mean divided by s and divided by the square root of the sample mean.
Yeah. So
But
do we have the sample? We do. We've got the sample mean. We just need the what? Do you have the?
I think maybe we're thinking. Shouldn't we just plug something on the on the applet or something?
He did do something with plugging something into the one sample or one proportion Z test. Come on. Enable editing. You're right. He did do something on the videos where he put, okay, so tell me, what was the X?
The X. The X is the top, the 38.
38. Okay, and then what was the N?
The N is 80.
Okay, and the confidence interval, we'll leave it at 95. And they want to know what the value was.
You're doing the Excel or what?
Yeah.
Okay. Yes.
That last Excel in this video, he brought up the last Excel, the categorical data analysis. And he told us just to input the stuff in there.
So X 38.
Yeah, 38 and is 80. What was the null hypothesis? It was 0.6, right? And we wanted to know less than. If I remember right, let me see. I've got to go back to it. So the hypothesis was 0.6. That was the null. And it was going to be less than. So then according to this.
But it don't tell you that the T.
Yeah, no, it does.
It tells
you. Yeah, it tells you the T if I can get on the right one. The T score is a negative 2.282.
That's the Z score.
That's the Z score. Do you want me to share my screen?
You're talking about the Z score, right?
Yes.
So, but with the Z score, we can get the T because we're looking for the T. The test statistics.
Now we're back to a Z score.
So are we in 15 already, or
we are? We are on number 15. Yes, we're looking for the test statistic.
Oh.
But for some reason,
Shouldn't it be we plug in the z-score and then whatever we got in the area in the applet? Shouldn't that be
That's
the
the
test?
probability.
That's not the test statistics.
I don't know what it is.
No.
I have no idea, Moses. Okay, let me share my screen with you guys.
Yes, yes.
Because this is. Did you guys watch the videos for this chapter yet?
No, I didn't watch the videos.
Okay, so they brought up this new applet here. It's the categorical data analysis PAT one. And all you have to do is one sample z-test for a proportion. And here it said...
Yeah, that's what I have open right here.
Oh, but, you do?
Yeah, but where's we're trying to get the T, right?
Well, you want the test statistic.
So what is the test statistics here?
I think it's this z-score right here, because on all of the other ones, the test statistic has been right here. See, if you look on this, well, no, not that one. That one doesn't help. But right here, it's the t-score. It's always this one right here.
Right. And next to the p-value.
Yeah, next to the p-value, and that one is the one that's the one that's next to it. So I'm going to assume that that's the...
Okay, but we can try it, and then we can submit one of those.
And then the next question asks you for the p-value, and the p-value is right next to it.
Yeah, 0.011.
Yeah.
Okay.
So what was
that works with Excel.
The z-score was negative 2.282, right?
Yeah.
Negative 2.82. Yeah. And then if
2.282.
Yeah, negative 2.282.
And then the p-value is
0.011.
And I'm not positive on any of this. I've only watched the videos twice.
Okay.
So now we want to know, okay, what was the alpha? Was it 0.5 or
yes, 0.05?
0.05, and this is 0.01. So then we would reject.
We reject
the null. Yeah.
And then the whole thing that sucks is if you mess up on one part of this, it messes up
the rest.
The whole thing. Yeah.
So if we reject the null, then there's sufficient evidence for the alternative. So there is sufficient evidence that it was decreased, that the area has decreased, right?
Okay, so is it the last one?
Yes. Gracias a Dios.
The last one?
Okay.
Yes.
Yeah, the last one. Okay, let me see what we got. Okay. Let me see.
You want me to submit?
Oh, I'm submitting right now.
You submitting?
Yeah, let's see. This is too slow. And you know that small screen there is too small that I can just scroll down all the time when I want to submit it. Okay, let's see. Okay, we missed one. Let's see which one is it, okay?
Oh, one only? That's good.
Yeah, we missed number 14. What is P? P with a hat is 0.4. Or maybe I did wrong. It's 0.471?
No. It's 0.475.
Oh, there it was me. Then you are right. Me is wrong. I put 1. I don't know why. Okay, then you are right.
So
I put 1 instead of 5.
All right.
Yeah. That's the only one that I missed. And then all the others are right. And so, the teacher will probably say, how they can get A's on the group.
Miss one.
Oh, you still miss one?
Yeah, let me see
which one. Number.
I got 100.
Oh, you got 100. Maybe Moss is something. Which one is it, Moss?
Did wrong.
Mine is 14.
I'm still looking for, hold on.